But if we just did that, this would not be a video about rate of change, now would it? So let's go ahead and shrink all of this a little bit. Move it over here where nobody can touch it. And do part B. So part B. Find the rate at which the water level is rising at the instant when it is 25 centimeters deep. So water level, that's height. dH dt is what we're looking for. What? And what they give us is that h is equal to 1/4 meters. That's 25 centimeters, right? Alright, so first what they want us to find is d theta dt. Now we're told at the beginning of the problem, if you were listening, that water is being pumped at a constant rate of 0.1 meters per minute, meters cubed per minute. That's volume. But also give us dv dt is equal to, I'm going to put it in fraction mode, 1/10 meters cubed per minute. Alright, so we have dv dt, and we know what dv dt, we know what v is, so we can go ahead and just plug that in right away. V is equal to theta minus sine of theta. Right? Oh, that's an ugly theta. Minus sine of theta. Which means theta is also dependent on time, by the way. So dv dt is equal to d theta dt minus, actually, minus cosine theta, right, times d theta dt. Factoring a d theta out and dividing, d theta dt is equal to dv dt times 1/1 minus cosine theta. How about we try finding what h is now? H is this length right here, the water level. H is equal to 1/2 minus, well, it's minus this length right here. And we can recognize that as 1/2 cosine theta over 2. Because in this triangle, if we split theta in 2, then we get this triangle right here. And the angle here is going to be theta over 2. The cosine of this is equal to the adjacent, which is this height, divided by the hypotenuse, which is the radius. The radius is 1/2. So 1/2 cosine of theta over 2 is equal to this blue part right here. So we can find out what our angle is from this, actually, and we can actually eventually find out what dH dt is using this. So first for the angle, factor out 1/2. So h is equal to 1/2 times 1 minus cosine theta over 2. 2h is equal to 1 minus cosine theta over 2. 2h is equal, minus 1 is equal to negative cosine theta over 2. 1 minus 2h is equal to cosine theta over 2. Then we find the arc cosine of both sides. So now we're solving for the angle, which is actually what we were doing this whole time. The arc cosine of 1 minus 2h is equal to 1/2 theta 2 arc cosine 1 minus 2h is equal to theta. Right? And we're solving for the point at which h is equal to 1/4 meters. Our cos 1/2 is equal to theta. That's just putting in our h value. The arc cosine of 1/2 is equal to pi over 3, right? Times 2. 2/3 pi is equal to theta. It's not the square root of 3. So theta is equal to 2/3 pi, which means d theta dt is equal to dv dt times 1 over 1 minus cosine of 2/3 pi. Cosine of 2/3 pi is equal to negative 1/2. And dv dt, we're just going to plug that in, it's 1/10. And we already know that from up here. 1 over 1 minus cosine of 2/3 pi, which is equal to negative 1/2, or negative 1/2. 1 minus negative 1/2 is 3/2, and 1 over 3/2 is 2/3. 1/10 times 2/3, which is equal to 1 over 15. And that's d for dh dt. So now we know d theta dt is equal to 1 over 15. Here's the stuff we know. So now we can finally solve for what dh dt is, now that we know all this junk. So let's go ahead and do that. So we have our h function right here. Bam. But an easier one to work with would actually be right here. Once again, bam. And I'm just going to write it again, way down here. H is equal, actually, screw writing it down again, I'm going to copy and paste it. dh dt is going to be equal to the derivative minus 1/2 times the derivative of a cosine. It's a negative sign, so this turns into plus sine theta over 2. That looks horrible. Sine of theta over 2. Come on. Yeah. Beautiful. Times 1/2 d theta dt. Oh yeah, almost there. Okay, so theta is 2/3 pi. Is equal to, so we don't forget about that 0. 1/2 sine of 2/3 pi over 2 times 1/2 d theta dt. This is why we need d theta dt, right? D theta dt we said was 1/15 times 1/15. And sine of 2/3, well, 2/3 pi is the sine of, this becomes the sine of pi over 3. 2/3 pi divided by 2, pi over 3, or 1/3 pi. So sine of pi over 3 is square root of 3 over 2. Okay, actually, let's multiply all these coefficients first. So 1/15 times 1/2 times 1/2 again is 1/60th. 1/60th sine of pi over 3. Sine of pi over 3 I just said was square root of 3 over 2. Which 1/60th times square root of 3 over 2 dh dt is equal to the square root of 3 over 120 meters per minute. That problem took a million years.